Hello, and welcome to another installment of the Barnstable Municipal Airport Master Plan Virtual Public Workshop video series. My name is Rick Lucas. I'm the project manager for the master plan, and today we're going to talk about the airside facility requirements. This will focus on the runways and taxiways. We encourage you to watch other videos in the series that lead up to this, as many of the information covered in those videos will build upon what you'll learn about today. I do want to caution you that this video will involve a lot of technical information. In addition, we encourage you to visit the project website, which is linked in the bio for this video. On the project website, you can find other PowerPoint presentations, draft chapters, a list of acronyms, contact information, project schedule, and other updates regarding the master plan. So now let's dive into the airside requirements. The airside facility requirements determine what, if any, additional facilities will be required over the next 20 years. Much of this is premised on the most demanding aircraft, whether it be a single aircraft or multiple aircraft, and it's also related to the forecast of activity, which was in a video covered previously. One of the key areas for Hyannis that we need to consider is the peak hour and seasonality as it relates to annual demand, and you'll hear us talk about this seasonality a lot in this discussion. What we're going to focus on today is the runway length, the runway width, the orientation and strength, as well as the design surfaces, and also taxiways and airfield geometry. Some of the elements such as the apron and ramp and aviation terminal areas were covered in the other video for facility requirements. There are two ways to approach the airside requirements analysis. The first of which is traditional methodology. This looks at the FAA requirements and guidance, much of which involves looking at annualized capacity, annualized weather data, and one critical aircraft. We would apply this approach to the configuration, the layout for each individual runway, and looking at the length, width, strength, and approaches based on this annualized approach. The other approach to this analysis is looking at the Hyannis Focused Considerations. As opposed to looking at things on an annual basis, we take a look at the peak summer season, which we know affects this airport greatly. We look at the peak seasonal operation characteristics, the peak season weather characteristics, the peak season wind, and also take into considerations things like the fact that this airport has commercial service, and what are the requirements of the operators for those types of airfield infrastructure. The crosswind coverage analysis involves annualized wind data from over the past 10 years conducted in hourly observations. The traditional analysis would tell us that runway 1533 only needs to be half of its existing width, whereas the Hyannis-focused approach would tell us that runway 15 is one of the most important IFR, meaning instrument weather conditions, runway for the peak season. These are two different stories, and it's very important to understand the difference between the traditional analysis and what is really going on at Hyannis. A deeper dive into runway 1533 tells us that runway 15 has the best approach of all the runways at the airport, and including the fact that the wind favors that runway for almost 6 months out of the year, and the IFR conditions, meaning the low visibility conditions, occur during the peak summer season. In addition, this runway has a higher pavement strength than what would normally be considered the primary runway. So what this tells us is that runway 1533 is really the primary instrument runway, whereas runway 624, even though it's a little bit longer, is really the primary visual runway. The airport capacity analysis is another highly technical piece of the puzzle when looking at airside requirements. The FAA requires that on an annual basis, anytime an airport exceeds 60% of their theoretical capacity, which is known as the annual service volume, or ASV, that the airport should plan capacity improvements. On an annual basis, the airport does not come close to that 60% threshold. However, when looking at the peak summer season and the peak season annual service volume, we do exceed that 60% threshold, meaning it's important to consider capacity. If runway 1533 was limited under the traditional analysis, this would hurt capacity, and it would shift most of the jet activity to one runway, which would result in a noise problem because the noise would now be concentrated over one runway as opposed to both runways. Whereas a fully capable secondary runway would support the peak summer volume and also help provide a balanced approach to noise impacts. And you'll hear more about that in the slides ahead. This balanced approach to impacts by maintaining both runways and their existing configuration and width allows aircraft to use the best runway for crosswind coverage at the time. It also keeps runway 15 as the best IFR approach compared to the existing ILS for runway 24. It also enhances operational flexibility during peak periods, and as previously stated, from a noise abatement and balance perspective, it distributes the noise profile more evenly across all four runway ends of the two runways, as opposed to concentrating it over a single runway. This type of detailed analysis is not uncommon for other airports in Massachusetts. Here's a comparison to some similar stories throughout the state. In Plymouth, the crosswind runway there was extended to help distribute the noise more evenly in the community. Over at Hanscom, outside of Boston, the crosswind runway was given the same design group category as the primary runway to help balance out the capacity needs as that airport is busier. And in Nantucket, their peak summer demands are even greater than Hyannis, and that triggers the need for a third runway. Another highly technical analysis for the airside requirements is the determination of the necessary runway length for the future. We start by looking at the existing users, so someone like JetBlue, which currently operates the E190 at the airport. The E190 is slated for retirement in the coming years, meaning the Airbus 320, the only other aircraft in their fleet, as well as the Airbus 220, which is currently on order, represent the existing users, in addition to large aircraft and corporate aircraft like the Gulfstream 5. We will get into future prospective users in the coming slides ahead, but it's important to note that since the last master plan, nearly all of the turboprop aircraft that have previously served the airport in commercial service capacity over the years have largely been removed from regional airline fleets. This changing fleet mix is an important consideration in looking ahead for the next 20 years. A look at the existing operation shows us that much of the existing users from the airline fleet are nearing the edge of their performance envelope, and they can barely be accommodated with the existing infrastructure, and in some cases there would be weight penalties involved. In addition, many of these commercial requirements involve 6,000 feet of runway for their real-world insurance requirement. In addition to existing users, we also want to make sure that we can accommodate certain aircraft in an emergency. FEMA recommends protecting for a Boeing 737 or also an Airbus 320 sized aircraft in the event of something like a hurricane, an earthquake, or accident that closes the bridges, meaning that the only way off the Cape is via air. Since aviation demand is constantly evolving, it's important to look at more than just the existing users and look at some of the potential users as well. The forecast section discussed a very strong local market, and we looked at the different forecast scenarios that we discussed and applied what those requirements would be in terms of runway length. As you can see, both commercial and general aviation, there are very few options of aircraft that can actually be accommodated on the existing infrastructure going forward. Some of them are somewhat close to the existing infrastructure, whereas some of them may not be practical under future considerations. However, it is important that we look at the overall 20-year future demand and take all this into consideration when looking at different development alternatives. It is important to note that larger aircraft does not necessarily mean a longer runway, as smaller aircraft on more demanding missions nearing the edges of their performance envelope may require longer runways than a larger aircraft would. Recapping some of the main points from the runway length analysis, airlines are retiring their fleets earlier, and some examples such as the Airbus 320 or 737 are common aircraft used by multiple airlines, that will typically persevere through airline fleet changes. In addition, many of these airlines also require a minimum of 6,000 feet of runway. This is often driven by their insurance requirements or their operating specifications compared to what their actual need may be. It's also important to understand and realize that the aircraft that serve Hyannis are a function of a larger, broader airline network, meaning that the aircraft that might be ideally suited for the runways at Hyannis may be based in a different part of the country, and the airline may not have the resources or means to route that aircraft through certain hubs at certain times to get it here, meaning that opportunities may be passed by if the facilities aren't adequate. The overall recommendation we're going to look to accommodate is somewhere between 6,000 and 6,400 feet if we can. We will allow the alternatives analysis and constraints to dictate what we can ultimately accommodate here at the airport. But it's important to note that the runways here at Hyannis are the shortest runways in the entire JetBlue network, and it's actually the shortest runway used by passenger jet aircraft in all of the Northeast. So now let's summarize the runway discussion between the two different methodologies we previously talked about. Under the traditional FA analysis, one of the runway's utility would be limited and there would be no runway extension. This would reduce the operational effectiveness of the airport. It would limit the peak summer season capacity and could potentially even include delays, which would result in additional emissions and noise on the ground at the airport. It would compromise the airport's access during IFR conditions. It would concentrate noise over only one of the two runways and 2 runway ends as opposed to 4. It would restrict commercial service opportunities as the airlines and fleets change, and it would restrict aviation in terms of weight restrictions and ultimately impact fuel sales at the airport. Contrasting that with the Hyannis-focused approach, which maintains the existing configuration, as well as proposes an extension to runway 1533, even though we don't know exactly by how much yet. This results in a balanced approach to safety and noise abatement. It allows us to accommodate new, quieter general aviation and commercial aircraft. It allows for commercial service to occur year-round from winter operations, because in the wintertime you have to allow for contaminated runways from snow and ice buildup. It allows the airport to maximize their role in supporting the local economy. It serves as an all-weather, all-season airport for the Cape and the islands, as well as emergency response as from an air bridge to the islands or in the event that the bridges are not usable. Now let's look at some other runway and airside aspects. Both runway 624 and both runway 1533 meet the existing C3 standard of 150 feet wide. With regards to pavement strength, in the event that runway 1533 is reduced in scope of what it can accomplish, or without a runway extension, runway 624 may need to be strengthened to accommodate some of the heavier aircraft in the fleet. While they're not physical infrastructure, runway design surfaces, which are imaginary surfaces, are important considerations for the airport. The runway safety area, which is immediately adjacent to the runway, the runway object-free area, which is just outside of that, as well as the runway protection zone, which is a trapezoidal area off the end of each runway. It's important that the FAA control the interest in land, either through fee simple or through easement, to make sure that nothing gets built in these areas, particularly the runway protection zone, which is out off airport property in some occasions, that nothing gets built in these areas that the airport would not be compatible with, such as any kind of thing that would encourage congregations of people or residential structures or any kind of obstruction to the approach to the runway. Moving from the runways to the taxiways now, there are only several minor changes that we need to take a look at. Most of them involve relocating the airport's perimeter road and or clearing some trees to make sure that the object-free area, which extends on the taxiway center line, is clear for the safe traveling of aircraft as they traverse their way to and from the aprons and or runways. The other key element of taxiways is looking at airfield geometry standards. Much of this involves looking at the angles at which taxiways intersect with runways and how the taxiways cross runways. This is important to make sure that pilots always have maximum visibility of the airfield environment and also that aircraft are not crossing runways at the middle of the runways at the time of which it's considered a high energy intersection, which means that aircraft taking off or landing have limited opportunity to maneuver because they're traveling at such a high rate of speed. The goal of the FAA is to standardize airfield geometry at airports across the country, and this will be a factor when we look at airside alternatives in the next step ahead. Summarizing what we've just discussed, we're going to look at runway length of how we can accommodate between 6,000 and 6,400 feet of runway, which is an increase from the 52 to 5,400 feet that exists presently. We want to make sure the airport owns and controls all the dimensional standards both on and off the airport. We want to modify the taxiways to address the geometry concerns and make any other minor improvements such as with runway visual aids and taxiway lighting on the airport. We acknowledge this was a very detailed and highly technical presentation, and we appreciate you listening and following along with us as we discuss the airside facility requirements. The following are project contacts if you have any questions, and we encourage you to email the link in the bio any questions or comments that you may have, and we will respond to those at a later date. We encourage you to watch other videos in this series and visit the project website to learn more about this project. Thank you again for watching today. We hope to hear from you soon.